Okay, for this I'm going to do 15 and 16 in the same video because they go well together. So for 15, we're asked to rationalize the denominator of this. And then this is about as straightforward as it gets. These do not reduce 11 and 6. There's nothing I can simplify out of there. And then I can't have radicals in denominators. And so the way that we can take care of that when I can't simplify it out like the earlier problems is to multiply it by a clever form of 1. And the clever form of 1 I'm going to use is root 6 over root 6. So again, that just equals 1. But when I do that, here's what happens. So, and remember in the earlier problems we had root a times root b. I could write that as root ab, so that means I'm allowed to multiply these things together. So that would make square root of 66. The reason I want to use square root 6 when I have a square root 6 is because now that makes a perfect square. The square root of 66 doesn't simplify because it's a 6 and 11, so it just stays there. And square root of 36 becomes 6. And so that's why whatever is in this denominator, generally speaking, if it's already simplified, which the next one won't be, but whatever this denominator is, if we multiply it by itself, that will allow us to clear the radical out of the denominator and get an equivalent expression. So let me pop over to the next one. Let's see, there and there. Okay, so then for this one goes 15 square root of 27. So there's a couple of things I could do here. I could do this, I could just do the 27, honestly. That would work too. Let me show that just as one possible way. Oh, I'm actually writing this different, and I'll just go ahead and do it. I could write it as two separate radicals, or in this case I wrote it under a single radical, and it's because it doesn't matter. They're equivalent. This is still just square root of 1 is 1. And now let me slip back to black ink. So this is going to be 15 times the square root of 27. And now square root of 27 times square root of 27, I don't know what 27 times 27 is, but I know when I take the square root, it will be 27 again. So the same way here, that root 6 times root 6 is going to become 6 because it becomes root 36. This is going to do the same thing. So for me, I never write this step. I just go, if I have root of something times itself, boom, you're right at the a, because it doesn't matter what it is. It's going to make a squared and reduce down to that a. So that allows me to, right here, get to that 27. Now notice those are both divisible by 3. So 3 goes into 15 5 times, and 3 goes into there 9 times. So let's get that much simplified. And that brings us to 5 square root 27 over 9. But we're not quite done yet because square root 27 simplifies. So that would be 5 times the square root of 9 times 3 over 9. And so what I'm doing there is like we did back in the early questions on the homework, I'm thinking of that 27 as a 9 times 3 because that's going to allow me to, I'll do it right here, 5 times square root of 9 would bring out a 3 times root 3 left inside, and then that's over 9. And then right there, that's going to reduce because that would be 15 root 3 over 9. When I go 5 times 3, and then 15 over 9, that would reduce down to 3 goes into 15 5 times, and 3 goes into 9 3 times. So that would be 5 root 3 over 3. So that was one way to get there. The next one probably won't be that great either, but it's probably what I would have done. So this is, if you didn't notice that 27 simplified, which you notice I did that right here on this last step, that was me simplifying out that 27 from there on. I could have simplified it first as well. So now let me show it that way. If you don't notice it, you're going to eventually get there, but hopefully this will be a little bit quicker. Let me clear these and rewrite it. So now thinking of that 27 as a, let me go ahead and do this, 9 times a 3, just to kind of show how I'm thinking. And now 15, if If I take the square root of 9, that's going to bring a 3 out front and leave behind a root 3. So now what I can do is reduce this part before I go make it bigger with that root 3. So let me go ahead and go 3 goes into 3 one time, and 3 goes into 15 5 times. And that gets me to, let me slip down here, so that's a 5 and root 3. So 5 survived up top and just root 3 down below. So I still have a radical in the denominator, so I'm not done, but I've got it simplified down a bit at least. And now let's do our root 3 over root 3. And so up top I'm going to have 5 root 3, and then down below root 3 times root 3 will make root 9, which then makes 3. So I think if you can spot ahead of time that you can reduce the radical, it's definitely gets you some easier math if you do that first. But if you miss it, you should still be able to get to the same answer. It's just it's more suffering if you go that direction. So my advice, like I said, the one that we looked at earlier, where if this had been 15 over root 7, this would have been super easy. We just do root 7, 15 root 7 over 7. Nothing reduces, it's all very straightforward, but as soon as that radical might simplify, that's where it's really helpful if you catch it and get that done in your first step. Hopefully that helps.